Okay, this is section 3.4, and it's identifying or finding an equation of a line, and this is problem number 31. Now, this one's a little difficult. There's a lot of steps to these, okay? So you got a point they're giving you. It's 0, 3. There's a stray mark there. I'll turn it into the L in the problem. L is x plus y equal 5, and they want you to do two things. They want you to write equations in standard form of the lines through the point that are first parallel and second of all perpendicular. I'm just going to make the symbol to this line. So there's two equations for each of 31 and 33. Okay. They want it in standard form. You know, they gave us the line that way. If you look at this right here, that's in standard form, right, where you've got the x and y on one side and the number on the other. So what am I to do here? Well, first of all, if I'm talking about writing parallel and perpendicular lines, I'm going to need to manipulate the slope. Standard form has nothing with slope in it, does it? So I can tell that I'm going to want to use another form. So what I'm going to do is this. What if I take this and I solve it for y? What benefit would that have? Well, that would put it in y equal mx plus b form. And then I could go play around with this because I could say, oh, I could plug a slope in. And then I've got an x1 and a y1 I could plug in. If I find that that's helpful, if I change to slope-intercept form, it gives me ways to work with this equation. And right now, I got nothing. I've got this. Just even if you try to plug it in 0, 3, you can see that's not going to work. 0 plus 3 is not 5. So you're like, what do I do? There's nothing here to do. Well, we change forms when that happens, and that's a big idea in math. All right, so let me take this x plus y is equal to 5, and let me solve for x. Let me subtract x from both sides. I would get y equal, and again, I'm going to write it with the x term first. I'm going to put the subtraction as the sign of the x, minus x plus 5. All right, well, let's see. I'm interested in the slope, because if I want a parallel line, if you remember, I want the same slope. And if I want a perpendicular line, I want the opposite reciprocal slope to plug in my new equation. So I need to know what the slope is. Well, it's negative invisible 1, right? So what is my slope here? It's the invisible negative 1. Now, if I want a parallel line for part A, let's do that first. What do I know about parallel lines? They have the same slope. So I'm going to have a slope in this line of m equal negative 1, and then I have the point 0, 3. Now, there's two things I could do here. This actually, if you look at it, when x is 0, you've got the y-intercept. This is the y-intercept right here. That's helpful because that's my b in y equal mx plus b. So if I want the slope, the easiest way to do this problem is to say if I have the m is negative 1, that goes in front of the x, and then my y-intercept here is 3 because this is x is 0, y is 3. It's the y-intercept, okay? So I could just say that, and I wouldn't probably leave it like that. I'd probably write that as y equal negative x plus 3. But they wanted it in standard form, right? So what do I got to do? I got to say, well, let me move the x and the y on the same side. I could add x to both sides to get the x and the y on the same side, and I get y plus x is 3. Now we're going to try part B, and that's going to be tricky because of the space I've got here, but I kind of want to look at all this work, so I'm going to try to put it in here, okay? For part B, we want the perpendicular line. Well, the perpendicular line has a slope that's opposite reciprocal, opposite in sign, and flipped fraction. Well, if my slope is negative 1, let me put it over 1. If I flip it, to get the perpendicular one, it would change the sign. So now it would be, my new slope would be a positive. This is my old one over here, but since this one's negative, the new one will be positive. And if I flip 1 over 1, I just get 1. Okay, so for part B, let me just kind of do this to separate the work. I can do the same, kind of the same thing as I did above, y equal mx plus b, but this time my slope is just 1. And I put it in front of the x, and I still know my y-intercept is 3. So now how do I put this in standard form? Well, in standard form, we want the x to be positive. So I'm going to leave my x where it is, and let me do this. Let me subtract 3 from both sides, and I'll subtract that y to move it over here with the x. I'm just going to do it all in one step since I'm short on space. So what does that give me? That gives me x, I'm just going to put the x's and the y's on the left, x minus y, and then since I subtracted the 3's, these canceled out, this y canceled out, and I have a negative 3. So that's in standard form what my line was, okay? 33 now, just because, now 33 would be done exactly the same way now that I look at it. I'm not going to, you need to do that one on your own and give it a, well, I'll go ahead and I get it because I see there is a little complication here. All right, so we have 0, negative 4 is our point. And I want you to notice something about that point. That is a y-intercept of negative 4 because x is 0, and you need to recognize those things when you get them. Had I not gotten a y-intercept, I would have had to use the point-slope form to plug the point in. Had I assigned you number 37, for example, you would have used the point-slope form. But I didn't. So we've got 33, that's our point. So our y-intercept's negative 4, and we have the line has an equation of 2y equal x. Now, remember, they want the parallel line, which we know will have the same slope. And then for part B, we want the perpendicular line, which will have an opposite reciprocal slope. But again, then they want it in standard form. So that was these are the conditions that we've got on us here. All right, I take this line 2y equal x. I cannot, right now, can't do much with this. But if I solve it for y, I'll put it in y equal mx plus b form, slope-intercept form. So that's what I'm going to do. I'm going to solve it for y. I'm going to put it into a useful form since I have choices about the way I can write the equations of lines. So I'm going to divide both sides by 2 to get the y by itself. And I get y equal x over 2, which I'm going to write it as 1/2 x, because if you remember, there's an invisible 1 out in front of that x. And so it's really 1/2, and I can separate those out like that. What did that tell me? Well, this is in y equal mx plus b form. So what do I know? I know what my slope is now. It's 1/2. By the way, on 31 and 33, we don't care what the y-intercept was of the original line they're giving me. All I care about from that is the slope. So don't go thinking you got to pull that off too. It doesn't matter. They're giving you they just want the slope off of it, and they say, well, basically you're just making a parallel line here that goes through a different point. So you just want the slope. That's all we needed from the first equation, and we got it now. We know our slope is 1/2. Okay? So let's start trying to do the parts of this then. First part A, we want the parallel line. Well, it's easy to mess with slope-intercept form, so that's what we're going to do. We're going to put the 1/2 in for the x. And guess what? They gave me the y-intercept. It was negative 4. That was the point they wanted it to go through. So this is really easy because I could put plus minus 4, which is the same thing as 1/2 x minus 4. And now I'm done with part A. Again, this problem was easier because they gave me the y-intercept. Oh, but I didn't do something, did I? I did not put it in standard form. So how does that happen? Well, we want a positive x. You got to remember. We want x and y on the same side and the constant on the other side, and then we want all whole numbers. That's what standard form is. So I got to do a little more work here. Let me come over here to do it. Now, if I want the x to stay positive, let me just leave it where it is, and let me subtract the y from both sides. And then I'm also just going to do 2 steps in 1 step. I want to move that constant to the other side, so I'm going to add 4 to both sides. I'm just moving stuff to the side it needs to be on. So the 4 is going over there, and the y is coming over here with the x. Y minus y adds up to 0 on that side, so that would end up being 4 equal 1/2 x minus y, because minus 4 plus 4 would be 0. Hopefully that's not hard for you now. You should hopefully be able to do 2 steps at once when you're solving. Now, another thing that's going on here that's not good, first of all, let me write 1/2 x minus y equal 4. I'm going to put the x and the y on the left side. That's how we like to do it. I'm supposed to have all whole numbers in front of really in the whole thing. So how would I get rid of any fractions? Well, there's a 2 there on the bottom of the coefficient to the x term. So in order to get rid of it, I'll just multiply everybody by 2, and that'll make the math police happy who don't like us to have these fractions in our standard form equation. So 2 times 1/2 x would just be x. 2 times minus y, remember you got to distribute to everybody. 2 times minus y is minus 2y, and 2 times 4 is 8. And that's my answer to part A. Now for part B, I'm going to pick a purple to work in. And let me just kind of section myself some space off so we can kind of look at what we have here. Now for part B, I want the perpendicular slope. If the slope of the line they gave me was this 1/2 up here, what I've got to do is change the sign so that makes it negative. And if I flip the fraction, I flip a half, I get 2 over 1, which is just 2. I'm not going to take the time to write all that down. That's my new slope. So I can say, oh, well, y equal mx plus b. I got the slope. It's -2, goes in front of my x. And in the y-intercept, they had given it to me in the problem. It was -4. And again, if I had not had the y-intercept, we would be using point slope form right now. So I've got y equal -2x plus 4. Well, the math police are going to be unhappy with this because the x and the y are not on the same side and the x is not positive. And that's what it takes to put it in standard form. So let's move this over to the other side. If I move it, it's a minus 2x. I could add 2x to both sides. And I would end up with what I need, 2x plus y equal -4. And that would be my answer to part B.